Hello again, everyone. Welcome to our discussion of section 1.6. Before we begin, I'd like to remind you that I hope you've already had a chance to spend half an hour to 45 minutes reading through the section 1.6. I hope that you've looked at the solved examples in the book and that you're in class attending and taking lecture notes, if not watching this video. And also that you are reviewing from lecture notes afterwards and you complete all the homework assignments by the due date, and then finally you continue to review these topics until the end of the semester. Okay, just that I wanted to remind you of that again, since still we are at the beginning of the semester. So here in section 1.6 is about applying the skills we learned about solving equations to word problems. A lot of word problem solving has to do with organizing the information you are given in plain English form, plain English text, to mathematically symbolic form. A lot of problem solving is that. And that goes for every topic, chemistry, physics, and so on. Each of these fields have their own formulas and symbolic applications, their own notations and symbols. So in mathematics, we have these set of symbols and forms you've seen so far. So the idea here is when we want to solve a problem like this, we'd like to translate this into symbolic form. Right now it's in plain English form. We want to translate that and organize that information in symbolic form and then solve it. Okay, so let's begin with this. It says, the first problem says that Mark invested $13,000. A portion of his investment earns a simple interest rate of 2.2% per year, and the rest is earning at a rate of 2% per year. So apparently Mark invested this amount in two accounts, right? One account is earning 2.2% and another account earning 2% per year. So we need to organize this information. We need to, and by that I mean we need to translate it into symbolic form that makes sense in mathematics. So to do that, let's assign variables to each of these accounts, right? So let's say that X represents the amount invested at, let's say, 2.2%. Okay? That's how we can, once we assign variables, then we are able to manipulate this information mathematically. So that's the first step, organize the information in symbolic form. So I've assigned one symbol so far to that information, which was given to us in plain English, right? A portion of his investment earns a simple interest rate of 2.2%. That's what that means. So the other piece of information is that, and the rest of the money is earning interest at 2% per year. So let's call that account Y. So the amount invested at 2%. Okay, you can use other variables if you like, but you have to assign variables to this information in order to be able to manipulate it and manipulate these in a mathematical way. Okay. Then, so because it was 13,000 that went into these two accounts, then we can establish a relationship between these symbols, right? So we can write X plus Y, these two accounts must add up to $13,000. And we're not talking about the interest at all. The interest we'll talk about, we'll consider in a second. But for now, we know that Mark had this much and he invested it in two accounts that each one had a separate interest rate. Okay. Then, after 1 year, the total interest earned on these investments is $278. That's very good information, because that is going to give us another equation to solve. That's important because we have two variables, right? Because we have two variables, we need at least two equations to solve for these two variables, okay? Or they need to give us some information with which we can write one variable in terms of the other variable. In fact, with some of these word problems that we go over today are exactly like that. Okay, so using that information about the interest rates, the total interest earned on these investments, that the total interest means interest from account X and from account Y, right, is $278. So let's translate that information into symbolic form, because right now, if I keep that information in plain English, I'm not going to be able to solve this problem. So I need to make sure that that information is translated into symbolic form. Okay, so the X variable had this much interest, was earning this much interest, right? So let's write it down. Or let's translate that. 0.022x, that's the interest from account X, plus the interest from account Y, 0.02y, added up to $278. Okay? So we have these two equations so far, that one and that one. One of the most common errors that I see, the most common errors, is that people, when they set up these equations, they write them like this. So the first equation is fine. They write that as x plus y equals 13,000. Then instead of writing it like this, they'll say 2.2x plus 2y equals 278. I mean, they completely bypass converting the percentage to decimal value. They completely avoid it. So let me say one thing. For most calculations, at least in mathematics, the percentage is used as, in word problems like this, to report something, or even on your credit card bill. You see percentages. So a percentage is usually used for reporting something. In newspapers too, when report statistics. They don't report anything in decimal, most things in decimal form, but they report most things in percentage form, not in decimal form. When you calculate something, you must convert the percentages to decimal form. Now, having said that, there are exceptions to that. But in this course, at least, we don't have any of those exceptions, as far as I can remember. Okay? In other courses, especially business courses, you might have exceptions where the formulas you have accept values in percentage form, not in decimal form. But that's very rare, and it's not in this course. Okay? So that's one thing you do not want to do. So please don't do that. This is not correct. The other error, common error that I see people make, is that the first equation is usually fine. They set up that one fine. But the second one, now this group does convert the percentage to decimal, or at least attempts to convert the percentage to decimal, but they don't do it properly. So instead of saying 2.2% is 0.022, they write 0.22x. Compare that with that. So this is 22%, not 2.2%. And they write, and the other one they write the 2% they write 0.2y. So that's 20%, not 2%. So once again, they are not correct in doing that. So please avoid doing that. Percentage is, I mean, I I don't care what profession you end up with, business, medical, mathematics, accounting, finance, marketing, percentage is an important part of your what you do, the numbers that you deal with as a professional. Even now on your credit cards, you deal with percentages. So please make sure you understand them. You understand what percentages are and how to go from percentage form to decimal form and vice versa. Okay, very, very important. All right. So now, once we have two equations, then we can we can use the method of elimination to get rid of one of these variables, solve for the other variable, and then plug back and solve for the second variable. So you can decide to eliminate any of these variables, x or y. I'll just, because y terms have an easier coefficient than x terms, I'm just going to eliminate the y terms. So I'm going to multiply the top equation by minus 0.02. Okay, so what we end up with is distribute this minus 0.02 into all that. Why am I doing this? You'll see in a minute. Minus 0.02x minus 0.02y equals minus, if you multiply minus 0.02 times 13,000, you get minus 260. Okay? So now let me write down the bottom equation as it is, 0.022x plus 0.02y equals 278. So compare the coefficients of the y terms in this problem. They are equal and opposite after I distributed the minus 0.02 into the top equation, aren't they? Okay, so that means once we add the two equations, those two are going to cancel each other out. So they add up to 0. Minus 0.02y and positive 0.02y add up to 0. We end up with, now minus 0.02x plus 0.022x, we end up with positive 0.002x on the left equals minus 260 plus 278, we end up with positive 18. So x then is 18 divided by 0.002, and x is 9,000. And this is the amount we're investing at 2.2%. Okay, so how much was invested in the other account? We can find that very easily, right? The other account must have 13,000 minus 9,000 because the total money was 13,000. So if 9,000 went into X, then the rest is going to go into Y. So then Y would be equal to 13,000 minus 9,000. Y is equal to $4,000, and that is the money that was invested at 2%. Okay, which is how much did Mark invest at each rate. Okay. The second problem we have, it says if Melissa invests $3,500 at 4% and per year, how much additional money must be invested at 5.5% annual interest to ensure that the interest rate she receives each year is 4.5% of the total money or the total amount invested. So at this point, it would be a good idea for you to pause the video, solve this problem, take 15 minutes, do your best, write down your solution, and then come back to the video. Okay, I'm assuming you've done that. So again, for all word problems, we want to translate this information to symbolic form. And that is going to help us solve the problem. We have to translate this information from plain English to symbolic form. And you have total freedom in how you do that. For example, in the previous example, I used X and Y. You can use M and N or P and Q, but you have to translate that information into symbolic form. So here, I'm going to begin with that idea. So it says, if Melissa invests $3,500 at 4% interest, so I'm going to write that down. $3,500 was invested at 4%. Okay, I'm just organizing that information per year. How much additional money? So as soon as I see how much, right, that brings to mind the variable, right? So I want to assign variable to any question mark that I see in the problem. So I say then, to translate that, I say this X is the additional. You can put capital A for additional money, but you need to assign variables of your own when you solve word problems. So additional money invested at 5.5%. Okay, so that is X, that additional money. To ensure that the interest rate, that's very important. Now they're talking about interest rate. So they were talking about how much money should be invested. Now they switch to the interest rate. So to ensure that the interest rate she receives each year is 4.5% of the total amount invested. Total amount, so let's write down the total amount. So the Y, let's call it the total amount. Okay, and invested at total amount is 4.5% of the total amount invested. Well, no, let's that. So total amount invested, right? That would be that. So if we have, if Melissa invested $3,500 at 4%, and we're wondering how much additional money should she invest at 5.5% in order to, for the interest she receives each year to be 4.5% of the total amount, then the total amount Y, we can put that equal to X plus 3,500, right? So Y can be equal to, or must be equal to, 3,500 plus X, because Y represents the total amount invested. You could take that as capital T for total amount, okay? But it should equal 3,500, which was initially invested at 4%, plus any additional amount that is being invested at 5.5%. Okay, so now we have enough information here to set up and solve the equation for the additional money that was invested. Okay, so let's set up the equation according to what we've been told. We were told that 3,500 was invested at 4%, because all of this, it has to do with the interest rate, right? How much additional money that we're looking for is connected to the interest rate she's looking for. Okay, so 3,500 at 4% means 3,500 times 0.04, that's the initial investment that she's made, right? Plus, we're wondering how much additional money should she invest at 5.5%. So plus X times 0.055. Again, please make sure you know how to translate percentages to decimal forms. Very, very important. Okay, so this is the initial investment, and Melissa has some additional investment at 5.5%. We're wondering how much she should invest at that interest rate, so that, let's read the rest of the problem. Must be invested at 5.5% to ensure that the interest rate she receives each year is 4.5% or 0.05% of the total amount invested. What was the total amount? Y. Okay? So notice what happened here overall. Take a look at the big picture. First, I went through the information, I read it, and I translated it into symbolic form. So X, that's how X and Y came about. That's how Y came about being equal to 3,500 plus X. Just by reading the information, assigning or creating new variables, and assigning this information to each variable. Okay? After that, after I introduced variables and attached information to it, just like what you've seen me do here in these two sentences, 2 lines here, and a little bit up there, then I was able to set up this equation by reading the whole picture, the whole problem statement. Okay? Now we have 2 variables, X and Y, and 1 equation. We cannot solve this equation right now unless we can write one of these variables in terms of the other, then we can solve the equation, because that'll be 1 equation, 1 unknown, and we can solve it. Okay, so let's do that, because we know that Y is equal to $3,500 plus X, because Y represents the total amount invested. We don't know X. If we know X, we know the total amount invested. So we're looking for X, but there's a relationship between the total amount and the additional amount of money that we're looking for. Okay, so in this equation, for Y, let's substitute with 3,500 plus X. Okay, so we have 3,500 times 0.04 plus X times 0.055 equals 0.045 times 3,500 plus X. Okay? All right, so now we have, take a look at this equation. We have nothing but X. So we should be able to solve for X, which is the additional money invested at 5.5%, which is the variable we're looking for in this problem, right? So let's simplify. 3,500 times 0.04, 140, that's according to my calculations. Please double check these numbers. That one is the same, 0.055 X equals 0.05 times 3,500 is 157.5 plus 0.045 times X, 0.045 times X, right? So now let's move all the variable terms to one side, all the constants to the other side, and combine the terms and solve for X. So we have 0.055X minus this, right? Move it to the other side. It was positive. When you move it, it becomes negative. 0.045X equals 157.5, which stays on that side. Let's move this 140 to the other side. It was positive on the left. when we move it across the equality symbol, it changes algebraic sign. So it becomes negative, like that. On the left, we have 0.01x. On the right, we have 17.5. And then x is 17.5 divided by 0.01. And so x is equal to $1,750. So this is the additional money needed at 5.5%. So additional investment needed at 5.5%. Okay. So as we go through each problem, please remember the overall approach. Don't get bogged down in the details of what happens to the numbers. You'll do that next. But first, make sure you follow the overall approach. The overall approach here is to introduce variables of your own. You have to do that. Then the second thing is establish a relationship between the variables that you introduced. Okay? Very, very important in solving word problems in any subject. Okay, so here, in this third problem, it says, what quantity of a 55% acid solution must be mixed with a 30% solution to produce 500 milliliter of a 45% solution? Okay, so here, it says what quantity. So let's give it, because it says, let's give it a variable. We have to introduce variables in a word problem. What quantity of a 55% solution? So I want to give that to, say, x. What quantity of that? Let's give that x variable, right? We assign that to x variable. Must be mixed with a 30% solution. But they don't tell us how much of the 30% solution, right? So mixed with a 30% solution, let's call that y, right? Amount. So amount, the quantity of 55% acid solution, and y is a 30% solution, quantity of. So this is the quantity of that. This is quantity of that. This is quantity of 55%. Quantity of that. Okay? To produce 500 milliliter of a 45% solution. So, see, mixed, what does that mean? That means added. So right there, by just doing what I'm doing, which is introduce variables, and take a careful look at these words that are used in a word problem, you can establish a relationship right there. So you have x plus y equals 500 milliliters, right? So let's write that down, just from what I've done. Notice what happened. Again, the big picture. Introduce variables to the information you are given in plain English. And then take a careful look at these key words. So x plus y is equal to 500. Never mind the units. If this was a chemistry or physics course, we would be careful about the units, very careful. But here, we're just, for now, let's disregard the units. Just focus on the relationship between quantities. That's important here. What are the quantities? Label them with variables, and then what is the relationship between those quantities? Very, very important. Okay, so that's that. Then it says, so now that we have that, let's see how we can solve this problem. What quantity of a 55% acid solution must be mixed with a 30% solution that to produce 500 milliliter of a 45% solution? So we're going to work with this equation, but we're going to expand it. Okay? So now, so this is just the amount of the volume. This is the volume equation. The equation for volumes. We know that the volume of X plus volume of Y should add up to 500 milliliters. Okay, milliliters. Now, but we have another thing going on here. We have the 55%, where is that? We have the 30%, where is that? We have a 45%, where is that? This equation doesn't talk about or doesn't make use of the concentrations of the acid. Okay, so we need to capture that information in what we're doing. So let's use this equation to do that. So the equation for the acid concentration would be this. For the X quantity, that happens at 55% concentration, right? So that's 55. So 0.55X, right? Now I'm involving those quantities, capturing this information, because this equation did not capture those concentrations of the acid. So now we're doing it. Plus, for the Y, we know that has to be 30%, right? So plus 0.3 times Y. Okay? Then, adding these two, we should end up with 500 milliliters of a 45% solution. So 500 times the concentration of the total mix, which is 0.45. Okay? So this is the equation for the concentration of acid. Okay? So this X had 55% concentration. This Y had 30% concentration. And the total mix, we wanted to have a 45% concentration of the acid. So that's the equation for acid. The first one was for the volume. It didn't talk about the concentration, right? Okay, so now once again, we have we have two equations, two unknowns. So we should be able to solve this, right? So this is the two equations we have. So we can substitute, we can use the first equation. In the previous example, here I used the method of elimination in the first problem. Here I used the method of substitution. Here, once again, we can use the method of substitution. We can find, because they're saying what quantity of a 55% solution, which is X, so I want to eliminate the Y term. So for that reason, I'm going to solve for Y in terms of X, because I'm looking for X, so I don't want to eliminate X. I can eliminate Y. So then Y, based on this, Y is equal to 500 minus X, right? So now in this middle equation, replace for Y with 500 minus x. And you end up with just one equation, one unknown x, and we can solve for it. Okay, so let's do that. So we have 0.55x plus 0.3 or 0.30 times 500 minus x equals 500 times 0.45. Okay. So now we can go ahead and simplify and solve this. So we have 0.55x, 0.3 times 500, that will give us 1 plus 150, minus 0.3 times x, right? Minus 0.3 or 0.30x equals 500 times 0.45, and that would be 225, like that. Okay. Okay, so let's combine the x terms. We have positive 0.25x equals 225 minus 150. So we have 0.25x. This is 150 moved to the other side, becomes minus 150. So equals 75. And then x is 75 divided by 0.25. And therefore, x is equal to 300 milliliter of 55% acid solution. Okay, so like that. Okay. Next problem. It says a health clinic uses a solution of bleach to sterilize petri dishes in which cultures are grown. Okay. So a solution of bleach, by the way, that means it's not entirely bleach, right? They don't use bleach, pure bleach, which would have 100% concentration. They're using a solution of bleach. So they've diluted the bleach with some amount of water. Okay? So that's what that means. Solution of bleach means it's been diluted with water. Okay, so the sterilization tank contains 60 gallons of solution at 4%. So that's a very important information. So I'm going to write it down. So 60 gallons at 4% concentration. Okay, or of ordinary household bleach. So the rest of it is with pure distilled water. So the rest of this, so this 60 gallon is 4% bleach, and the rest of it, the 96% of it, is pure distilled water. Okay, it's a solution of bleach. It's not entirely bleach. So new research indicates that the concentration of bleach should be 6% for complete sterilization. So apparently 4% doesn't kill all the germs that they want to kill or they want to get rid of. So it has to be 6%, not 4%. Okay, so how much of the solution, that is the current solution, this is very important, how much of the solution, that is talking about the current solution of 60 gallons of this solution at 4%. How much of this should be drained and replaced with bleach? With bleach. That means 100% bleach. Not a solution of bleach, but they want to increase the concentration of the 4%, right? They have a solution at 4%. To increase that concentration, they want to add pure bleach to it. And so how much of the solution of this solution must be drained and replaced with bleach to increase the bleach content to the recommended level of which we know it's 6%, that one. Okay? All right, so let's read this problem one more time and then write things down as we put together an equation. But looking at this, we need to introduce one variable, right? Because of this phrase, how much, it tells us that we need at least one variable. How much of the solution should be drained? So let's introduce a variable and call it exactly that. X, the amount of the 4% solution to be drained. Okay? That's what X is, and that's what we're looking for. Okay, now we're ready to set up this equation. So originally, when we start with, what do we start with? We start with 60 gallons of 4% solution, right? Let's translate that into symbolic form. So 60% of solution at 4%, there. Okay, 60 gallons of that. Then we're wondering, we want to increase this 4% concentration to 6%. So some of this 60 gallons should be drained. And we just call the variable after that. X is the amount of the 4% solution to be drained. So if it's being drained, so it's not a positive, it's a minus, right? Drained means subtract, right? So minus X times, what is the solution that we're draining? The 4% one. So X times 0.04. Okay, we had this much, we start with this much, we drain some of it, we don't know how much it is, that's why we assign variable to it, and that's the 4% solution that we're draining, right? 4% of the bleach, it's 4% bleach, the rest is pure distilled water. Then, and replaced, so replaced, drained, I just said drain means subtract. Replaced with bleach. So add pure bleach. Right? Pure bleach is 100%. 1.0, right? When you convert 100% to decimal form, you get 1.0. So replace means add pure bleach. These are the clues you should watch out for, because drained means subtraction. Replaced means you're adding. So plus pure bleach, right? Pure bleach is 1.0. But how much pure bleach? Well, the whole thing should add up to 60 gallons. So how much you drain? It should be equal, the amount of the pure bleach that you add, it should be equal to X. So plus X, that same amount. Let's say 10 milliliter that you drain, right? Then 10 milliliters you should add, because in the end you want to end up with 60 gallons. Okay, if you're a factory manufacturing this, then all the gallons that are going, all the containers that are 60-gallon containers that are leaving the factory must be at 60 gallon, right? So you want to know how much adjustment you need to make at the factory. So how much you should drain from the current gallons that you have, and how much pure bleach you need to add in order to increase the acid solution or the concentration of the bleach in this gallon to 6%. So X of what concentration? 100% concentration or 1.0. So this is, let me make this clear, this piece, this is total initial gallon. So this is initial gallon at 4%. So this is draining X amount from 4% solution. This is replacing, I'm using the same words, replacing, so we're adding, replacing X amount of 100% bleach. Okay? And then that should be equal to what? It should be equal to 60 gallons at what concentration? 6%. So 60 gallons at 6% or 0.06. We're doing the draining and replacing so we can end up with 60 gallons at 6% solution. Right now we have initial gallon at 4% solution. Okay? So now we have this equation with just one variable X, which represents the amount of 4% solution to be drained, which is what they asked for. How much of the solution should be drained? Because if we know that, we'll drain the gallon from that, it's the 60 gallons. We drain that much from the 60 gallons, and then we add pure bleach to it, to the container. Okay, so then let's solve this. So this is 60 times 0.04. This is 2.4. Then minus 0.04x and plus x. That's just 1.0 times x is just x. Equals 60 times 0.06 is 3.6, right? So let's combine the like terms. These two added, we get minus 0.04x plus 1.0x is positive 0.96x equals 3.6 minus 2.4, that is 1.24. Okay, then x is equal to 1.24 divided by 0.96, and from that we have x equals 1.25 as the result. So this is the $1.25. This was in gallons, so we need to drain this much, or gallons to be drained of 4% solution and replaced with pure bleach. Okay. All right. So with that, we have wrapped up another section. Once again, thank you for staying or persisting through this video. Think about, especially with word problems, think about the big picture. What have you learned about this that you can translate into any course you're taking? Whether it's a chemistry, physics, accounting, finance, economics, all of those, if you're solving a word problem in all of those courses, you need to introduce your own variables and then attach information to those variables and then associate those variables to each other in a form of an equation or some kind of a relationship that then you can use to solve the problem. I hope you got this big picture of how to approach a word problem. So a lot of it is really about organizing the information before you solve the problem. Most people try to solve the problem immediately, which does not work very well. So you need to organize the information from in English, plain English, into symbolic form. That's at least 80% of solving any word problem. Then you solve it. Okay, and have a nice day for now, and I'll see you all next time.